can switch. Python is using curly braces for something else.
Hello and welcome to my live stream. Today, there's that microphone again, so now you can actually hear me. Welcome to the Computer Vision Power Hour. So today we're going to do some more cool computer vision stuff. This week we're going to do a little bit more with the car detection algorithm. We're going to see if we can tighten that up a little bit, and I want to count the cars in the screen. Maybe we'll do a little pedestrian algorithm stuff. I don't know. We're starting a little bit early so we can get a little bit more time in. And yeah, I'm really glad that everybody's joining me. So far, I see one person joining, but there will be more. And feel free to throw any questions you might have in the chat. Let's bring up the screen here. There we go. So, like I said, feel free to throw anything in the chat if you have any questions about what we're doing. So last week we did some, let's see, we'll get this thing set up so I can run it again, but we did some car counting, and we really refined it so that it worked a lot better than when we started. We had a ton of false positives. It was picking up things all over the screen. We've got it now to where it picks up most of the cars. I think we're gonna polish that a little bit, and then we're gonna try to count it, and we'll just we'll play around with a bunch of different stuff today, and hopefully you'll learn something about computer vision. I'm going to do a quick tech check here real quick and just make sure that things are going where they should be going. It looks like, yes, we are live on Twitch. Let me check and see if I'm on YouTube also today. That is another place where I am streaming today. And yep, sweet. Looks like we are on YouTube also. So yeah, feel free to drop stuff in the chat. Let's get started. So I need to create a Python environment. Now what I've done here is we'll do git pull. I put all this stuff on GitHub. Everything I do on here, so we're just pulling down the newest GitHub repo. We'll make some changes, and then I'll commit it today after the stream, and all will be well in our world. So Python -m OpenCV, we'll just call it OpenCV. Whoops. VNV OpenCV. Activate our Python environment. Yes. And we're going to do a source. OpenCV bin activate. There we go. Now we're in an OpenCV environment. And that's something that I like to do. I stress that all the time on the stream and on my blog is you should always use Python virtual environments. Keeps everything kind of containerized in there. You can really control your software that's installed or not installed. OpenCV Python. It says use cached NumPy. We'll do pip install upgrade pip install NumPy and pip install Streamlink. Because we're using Streamlink with our Find Cars PY, which is one of the first things we'll work on. We'll jump back into Find Cars PY. This one has been something that we've worked on for a few weeks now. So let's do Python findcars.py. There we go. And this is where we left off last week. Remember we were displaying what we're passing into the classifier. So that way we could kind of visually see what we're doing and then have a visual screen of the actual detection going on. See the little boxes being drawn. Everything is cool. Now I want to put in a counter in here. And so that's a little difficult, but I got some notes. I've done it before, so shouldn't be that hard. But we'll just put in a counter that shows how many cars are on the screen right now. Now, as we can see, this is okay. It's not as many false positives as we got when we first started this out. So that's encouraging. But it's still not as good as a lot of the ones I've seen online. It looks like my bit rate, someone just messaged me, my bit rate is a little too high maybe, or too low. I don't know. Let's see if I can change the bit rate a little bit here. And I believe I was able to do that. Apply. Let's see if this... Some of these you can change kind of on the fly. So we'll see if that helps the bit rate a little bit. If not, I'm not going to sweat it too much. But yeah, so this is a live camera happening right now. And I feel like we watch this one so much. And this is at like a church, I think, in Minnesota, Grand Rapids, Minnesota. But I feel like we watch this so much that someday we might see an accident or something. I hope not, but it's certainly possible as much as we watch this camera. And so I did want to do a little bit of another change with the morphology on this one before we put in our counter, just to kind of play around with it. So we got scale factor, mid neighbors. We can change a lot of these. Like, let's change the min size. I think we can do 40 by 40. Let's just see if that changes anything. And yes, we'll install that. Python find cars.py would help, right? Let's see if we change that minimum size, if that changes anything. And that is showing this piece of snow as a vehicle, which I suppose when it's blurred and dilated and everything else, it probably does look a little like a vehicle. We're still having some stuttering going. I have a different video card in today. I have a 1650, and I think that is part of the reason for the stuttering that we're seeing. I'm not really sure. So this one's picking up vehicles about the same, maybe a little worse. So we'll change this back to 3030. What about mid neighbors? Let's scale that up to 5. Let's see what that does. If that changes anything. So it's okay. And part of the thing is these things are moving so fast. It's kind of unfortunate that we can't hold the vehicle it's detected and follow it very well. But we'll keep polishing this thing. We'll keep trying to make it work. Whoops. Maximize my screen. Opening up the chat screen. So if folks have any questions or anything, we can do that. Let's look at what we've done so far with this. This is our detect vehicles, and it's huge. So in here, we're doing some contrast control, contrast and brightness. We're throwing it into a NumPy array. So we adjust that contrast and brightness. Then we make it gray. Then we equalize the histogram. Then we're putting a little bit of Gaussian blur on it. We can play with that a little more too. And we were doing, here we were doing some edge detection, and we found the edge detection wasn't that great. In fact, we'll put that in here. We'll put in our edge detection as our final image. And I'll show you that it does detect edges, but there are far too many edges in this video for this to be effective. So as you can see, we do have edge detection, but we also just have so many edges that none of these are picked up and classified as vehicles. So edge detection does work great for computer vision in a lot of cases, but I think with the angles that we have and things like that with this, I just don't think it's the right call. Obviously, we can see that it sees nothing. We can go with a wider, and maybe if we dilate it or something, but I think it adds a lot of noise. I mean, we can see it. That's part of the reason we're doing the preview screen where we can see what we're passing to the classifier, is so we can just see it. And see, this is just a ton of noise. I mean, you can barely see the vehicles with your eyes if you don't know what you're looking for. But yeah, the edge detection just did not help us in this case at all. So that's why I went back to the blur image. We can try the dilated image. I remember that we dilated it a little bit. And if I remember right, that worked okay. Yep, we're seeing two vehicles here. Dilating works. It also throws a lot of false positives all over the place, including the VidCom Technology logo. So, I mean, this, you know, it works okay. Oh, and I was going to throw a morphology in here. Let's do that really quick. So we have a dilated image. Let's dilate it a little more. So a lot of this is just hunt and peck, trying new things. And yeah, a ton of false positives. So I don't think dilation is our key either. But it is still picking up a fair amount of vehicles. So we'll go back here to blur. And we could even go back to gray and just see what gray does. But I do think blur helped a little bit last time that we did this. Blur was handy. Yeah, we're not getting as many false positives here without it being blurred. But we're also not picking up a ton of them. So yeah, I would say the blur helps us. We'll stay with blur for now. And I will drop in some code here. I'm going to try some ellipse structuring. See if this helps us at all. So with this one, we're doing an ellipse and we're just changing the structure. And you'll see when we do it here, instead of dilated, we're going to go with blur. And then our final image is going to be closing, and you'll see what it looks like in our preview. And we'll see if this works a little bit better. This one I stole from one of my other applications. And see how it kind of blurs it. It makes it a little bit... it's trying to make these things into kind of blocks that the classifier can recognize. And I don't think that this is helping. Honestly, this does not look like it's helping very much. So we can try increasing our kernel size. That's something that we do a lot on here. We'll do the same kernel size that we did for dilation. This should make it bigger and chunkier. Maybe a little too chunky, as you can see. That's like almost almost unreadable, but strangely enough, it is still picking up vehicles. That's kind of wild, right? Still showing vehicles here. So we're showing quite a few with that one. So 3 and 3. Less chunky, but only showing one vehicle. All right, so let's count these things. Let's stick with this algorithm right now that we have, and let's put a little counter in here that counts how many vehicles we see on the stream at a time. It's a little bit tricky. Like I said, I stole some code from another app that I did, and we should be able to count these roughly. And yes, it will count false positives also. But, okay, so in here, we're going to import dlab. Pip install dlab. Oh. Why would dlab already be installed in here? Interesting. Okay, so we're going to go to here, and we're just going to do a bunch of changes in here for dlab. One of the things is we're going to put a list of trackers in here. So we'll just do a... What dlab does is... we'll just do an empty list. What dlab does is it does some tracking. So every time that thing pops up, we're going to be able to store it in dlab, and we'll be able to hold on to it a little bit and say, yes, we have this. So if another one comes up, it's going to say, oh, we've already got one of these here. And that's what the tracker part of it means. It's like we already have this square identified. And so it keeps kind of a temporary list of these trackers. So let's see, we're scaling this down. We're going to keep scaling. Yeah, we'll keep scaling this down. That part will be fine. And we're going to put in a counter in here. So we're going to do this every, say, 10 frames. We're going to update these trackers. If you update it every frame, it just does basically the same thing that we have now, where it loses it. Oh, and we need a counter up here. So counter is 0. So we'll say every 10 frames, we're going to do this stuff. And we can even do this, whoops, with our, with how it's set up now, we can make it so it only detects vehicles every 10 frames, and it kind of holds it a little bit longer. And see, this is actually, by doing this, we're making it so it follows the vehicles a little bit better, if you notice. You notice how we're grabbing a vehicle, and it's actually following it a little bit better just by doing that 10 frame skip there. 20 might be too much, but let's try it. Let's draw one every 20 frames. Yeah, see, not bad. It's following it a little bit better. I feel like these rectangles could be a little bit bigger also. But that's fine. We'll mess with that later. So we've got our detect vehicles, CV2 rectangle. We're drawing this. Oh, and we're not detecting. I put the counter in the wrong spot. So we're only drawing every 20 frames. We're not actually detecting every 20 frames. So let's do that really quick. All right. So let's make it detect every 20 frames. Not super great, but it is at least holding onto the vehicles a little bit more. So we're kind of slowing things down. We'll put this back down to 10. And that should be fine. So we'll do this and we'll clear our trackers. Yeah, we'll clear the trackers every 10 frames also. And we'll see in a minute why that matters. Tracker's clear. So now we need to go into our list here for in each vehicle. So this is a for loop that every time a vehicle comes up, it goes through this, draws the rectangle around it. In here, we're going to have to create our trackers. So we're going to create a new tracker. And it's going to be DLive correlation tracker. And so this is basically going to assign a unique value. It's going to take each car that we detect is going to become a unique value in a tracker, and we're going to track those in a list. So we've got our rectangle here. We're going to do a DLive rectangle instead of the CV2 rectangle. So I will comment this out. Actually, I'd really like this to be on one line anyway. Comment that out. And now we need to put in our DLive rectangle. DLive rectangle, yeah, that looks right. X plus Y, Y plus H. I believe that's right. And then we'll start tracking that rectangle and the resized image. And now we're adding this into a tracker, and then we will append it to our list of trackers. So this is just basically putting a tracker on it. Let's make sure that our rectangles still come up. And they do not. But we're tracking them. So got some other code here that loops through our trackers and draws rectangles on those. So for each vehicle, counter is 10. Yep, we do that. Now, so you didn't have to watch me type it in, I say for tracker and trackers, update the tracker with the resized, with the new image, get the position of the tracker that we've created, draw a little square around that, and then we'll take the resized image with the new square and put a rectangle around it. So this should show us our rectangles again. There we go. There is our rectangles. Seems to be going pretty slow here. I feel like this isn't the actual speed of the video, but I'm not incredibly worried about it. So now we need to put in, I want to put in something down here that's just a text that says how many trackers do we have right now. Now, one thing I'm going to do is I'm going to take GIMP. We're going to create a screenshot of a single window after 2 seconds. And I'm going to screenshot this, and I'll show you why. Now, in here in the GIMP, I can see my coordinates of this image. So I'm thinking of drawing it here. Could draw it up here also. Guess it doesn't really matter. But I'm just going to draw on there how many vehicles are on the screen right now. So let's just start right here and say right about 50, 450. Let's keep those in mind here. And under resized image, before we show it, we're going to put some text on it. Text to image. So we're going to say resized image equals CV2 put text. Resized image. Yeah, let's say string counter, but we can say vehicles plus our counter. And then here in our autocomplete, it's showing 1030 for the coordinates, but we wanted like 50, what would we say, 50 by 450. So put that there. CV2 font Hershey Simplex, that's fine. And then here we'll have our, I believe it's thickness and color. So thickness is fine. Color, let's make it white for now. And these are just RGB values. What is the next one is the thickness. We'll make it thickness of 2. And then draws a text string. So we'll do CV2 line. Let's see, line 4, line AA should be fine. This is the actual line of the text. So this should draw out, say, vehicles and then a number. And it should be that counter. Let's find out. Can only catenate. Yeah. Need to turn the counter into a string. And there's our little thing here. And it looks like our counter, I'm not incrementing it because it's saying vehicle 0. So for tracker and tracker, we'll increment that counter. There we go. And holy moly, our counter's going wild. So that was not the right place to increment the counter, clearly. Because the counter's just going wild. So I think every time we create a new tracker is when we'll update the counter. That makes a little bit more sense. Okay, yeah, that makes a little more sense. So we can see we have 3 vehicles on the screen. I mean, it's a false positive, but... And I think I'm going to change that text a little bit, because it's a little low. I didn't expect it to be that big. So let's say put it at 420. And we can make this text green so it's a little more visible. And once again, we're showing 3 vehicles. Let's see what happens when we get more or less vehicles detected on the screen and see if that counter changes. It should. If we can get it to change. I'll change the algorithm a little bit if I have to. So yeah, that vehicle that it just detected should go away. Oh no, it just moved it over to the traffic pole. So we're stuck on 3 right now. Let's change, let's go into detect vehicles here. Maybe instead of this, we'll bring it back to blur for our final image. And see if that's a little bit more dynamic. We're looking for it to be more dynamic. And it's interesting that it that the little tracker lands on that. It lands on that traffic light and thinks that the traffic light is a vehicle. So now we're down to 2, so our counter is working. It's just not quite as dynamic as we would like here. It's not finding most of the vehicles on the screen in this particular one. Let's try a different stream really quick. Let's go to the, I believe this is the Amsterdam one. And let's go here and see if this one looks a little bit different. There we go. So this is our Amsterdam camera. Looks like it's picking up 2 vehicles. And it refuses to let go of those 2 vehicles. See, I've never seen this before where it just wigs out like that. But yeah, I think it's like 7 o'clock in Amsterdam. We've talked about this before. This one's cool to use at night in the United States, but right now it's kind of evening time. And I think this is our pre-recorded stream that seems to go super slow, but it's like pre-recorded cars going through. And I can just jump on YouTube and find another one. And that is my work calendar. I'm keeping open in case someone from work needs to... There we go. Yeah, this one is super slow, especially with this video card. But look, we've got 1 vehicle. I really don't like doing these pre-recorded videos as much because they're so slow. YouTube live camera. We got the Times Square camera.
Do you want to grow your YouTube channel? Do you want to earn more views, more subscribers?
And I will mute that.
And of course,
So we see 1 vehicle. This one's just entirely too slow to work with. So I'm going to put a note on there. Too slow Joe is what we're going to call that video, just so I can remember in the future. This is Times Square. Let's see what's going on in Times Square. Back to our restream chat. Times Square, it sees only 1 vehicle. And part of the problem with these is the angles. I've noticed this HAR classifier does not like vehicles at an angle nearly as much. I'm just going to find a different cam. Webcam. I'm going to say live traffic camera. Village of Tilton. No idea where Tilton is. That is also in an angle. But it is a nice wide shot. Let's call that Times Square. This one, video URL. This one has a nice wide shot with less noise in it, so this Village of Tilton might actually work pretty well, even though for some reason it's going super fast. But spotting 1 vehicle, but you see what I mean about the less noise. There's not as much noise here, so we should be seeing a lot more. We're seeing, let's see. I'm gonna see about slowing down the frame rate. OpenCV reader. Because we've had this problem before where the frame rate is just too high. This one's how to improve the frame rate. The slow, naive method to reading video frames, which is probably the one I'm using. Let's see. This one is for reading. Yeah, that was interesting how it just died like that. FPS. How are we grabbing the FPS? File FPS. Grab frame, stream. Oh, I see. It's doing a stream read. Threaded video file system. I mean, I could try that. So here in main, we're doing video capture. Utils. Oh no, that isn't going to work on this particular one. Nope, that is not going to work with a streamed video, I don't think. CV2 video capture, stream URL. We can put in some arguments here. Do an argument parser. Import that argument parser. Arg parse. Path video. Required true. Path to input video file. For that, we're going to put in our stream URL. And I think this will work. This gives us some arguments that we can pass in here instead of the stream URL to tell the capture that it's a video, and then maybe play with those arguments a little bit. Nope. /v. Following arguments are required. /v//video. Okay, we've got those. Video, yeah. So I just put it in there wrong, but yeah, it's still. Video required true, help stream URL. So let's see what I'm doing wrong here. Oh, I see. I need to put it in. To actually pass this argument in, which will be this one. Paste in our YouTube link and see if this works. Nope, does not work with GStreamer. So, okay. Just yank all this out of here. We don't need this. We'll go back to where we were before. And we might do some of those cap set settings, and we might change some of the stuff on our capturing, which we tried to adjust the frames per second on that earlier. As you can see, we use spotting one vehicle that's not a vehicle. So even though this one is really clear, we are having a heck of a time. Look up some capture properties here. We have a bunch of them. Cap G-Streamer. So it's using different, let's try that. It's using different APIs. So cap set, we can set the frame width, and actually our frame width is 1920. Height's 1080. So we're at least being explicit in that area. But interesting. Auto exposure 1. Let's see what that looks like. I guess we don't really need to pass this in, do we? This one does an auto exposure, which that might be handy. Like a handy thing for us to look at. And I'm just going to see what cap prop auto exposure. I'm going to see what tab 9 suggests here to do. MPEG. I believe it's using the FFmpeg library. And interestingly, our preview just not showing a thing. Preview's frozen. So let's make sure our last change was the reason for that. Probably was. Huh, maybe not. Probably the auto exposure. Let's see what froze up our preview frame. Is it the explicit height and width? Because that doesn't make any sense either. Yeah, it's just frozen. And I'm not sure why. Let's try a different feed really quick. Go back to one of our faithful feeds that we use all the time and see if that changes anything. Nope, that one's frozen too. Very interesting. What did I break? Because our preview frame is certainly not working. I mean, we can still, it's still doing its job, right? We're still able to look at it and say, okay, this is where my contrast and all this stuff is coming in. However, it's just a still frame, which is kind of annoying. And I'm not sure exactly why it's doing that. Image vehicles. Definitely has something to do with these capture settings I've been playing around with. And it still says 2 vehicles, neither of which are vehicles. So our classifier is just thoroughly confused today. So we have cars, smell, what do we do? Final images, blur. Let's see. what was this, 2020 before? We'll go look and see what the original settings were for that. Now we're picking up more false vehicles. We go to the OpenCV demos. And I'll post this in the chat. And looks like my YouTube is in an error state for whatever reason. So I will check that really quick here. Interesting. So I do see a viewer here, Pratik. Thank you for watching my stream. I apologize, I did not see your chat message because for some reason my chat is not picking up YouTube. Try this again. There we go. Now it's reconnected. Perfect. Okay, so here we're getting some serious false positives. And for one reason or another, our preview screen has frozen up. Something I did at some point. We've got a faster frame rate on here. And we have no vehicle detection. It's always a bummer when you make a bunch of changes and things get worse. But it's part of the game. So originally my settings were scale factor 1.1, min neighbors 3, and 30 and 30. So this is what my original detection was here. So we'll go back to that. And yeah, it's picking up more vehicles now. It's also going way slower now. It's kind of in slow motion almost. Let's see if we can find out what's going on there. Frames per second. I don't think we need to set the auto exposure. It's pretty well exposed anyway. Yeah, so setting the auto exposure looks like slowed it down a little bit. Now we're back to a normal speed and we're showing 4 vehicles. So our counter's working at least. It's just still not really detecting vehicles all that well. It's doing a little bit better. It's tracking. And let's see where these boxes go after it's done following the vehicle. It should disappear, but looks like none of them are disappearing right now. And that one actually passed the tracker to the semi-truck. There we go. That should have disappeared. It did not. It's just staying along the screen. So we still got some bugs. We got lots of bugs. And bugs are fun because bugs give us something to do. I do feel like I need to clear trackers. I mean, I am clearing them every 10. It should clear, and I don't know why that's not. Try tracking the clears here and see if that. This might just kill all of them. Yeah, it kills all of them. We don't want to do that either. Tracker start tracker. It starts it on resized image and rectangle. This is creating our dlib rectangle. Try drawing the CV2 triangle there. It's terrible. Big old false positive right there in the middle. A little bit better. Not sure why this tracker isn't tracking. Like none of these want to move. So let's mess with it. So we're capture read, not read break. We're resizing it to 800 by 800. We could, let's see, resized image. I mean, we could just take this frame, instead of resizing it, try passing it in full size. So instead of resized image, frame, another resized image, frame, frame, and frame. Frame. Just go through all of these really quick. Let's do a full size capture just to see if it behaves any differently. But generally you do want to resize it. Let's see, we're getting some more false positives. Of course, that one's still seized up. But yeah, this isn't really helping the detection, I don't think. Yeah. Resizing always makes it faster anyway, so we're just going to stick with that. Doesn't really affect the processing usually. I think we have a different problem in here today. So final image. Where's processed coming from? It's pre-processing. Processed vehicles. Processed vehicles. Detect vehicles from resized image. I see why it's freezing up, because I put that counter in there. Like I said, every 10 frames counters, and that messes with the detect vehicles. So if we just move this counter down here, then we'll get that preview back, and it's going to detect vehicles every single time, which maybe that's what we want. But see, now we have the preview screen going again. But our vehicle detection still sucks. It still needs some work. I'm not sure how this thing got so bad. Other than us just tinkering with it endlessly. So let's check some of this stuff. We have scaling factor, resized image. So we're just rescaling it to 800 by 800 We can make it just a little bit bigger. 1000 by 1000. Rescaling it, so this gives us a resized image. Equals CV2 resize. Then we're going to detect resized image classifier path. So a resized image here is what we're passing in. Then we're doing counter in vehicles. So vehicles is the other thing that comes back. Got our tracker, count +1. We're doing a dlib rectangle, tracking that dlib rectangle, and appending it to our tracker list. Then for tracker and trackers, we update with resized image again. Maybe we should be, instead of resized image, we should be doing tracking processed. Tracker update processed through all of these. Or maybe I'm really confused. I'm probably really confused. Oh yeah, because I'm drawing rectangles on the pre-processed image. Which means I'm confusing myself. So instead of processed, we should call this pre-processed. Right? So we don't get confused like that. Pre-processed means that's the one that we're just passing through it. The input that goes into the detect cars function just comes right back out through this pre-processed. And then we're showing it over here. Pre-processing, pre-processed. But resized image is the image that we want to work with. So we're doing CV2, resized image. Then we're passing it into pre-processed vehicles so that we can get our vehicles out. So for each vehicle, setting up a tracker, we should be drawing an image, drawing a rectangle, but we do that down here. And what happens when we do that up here? I don't remember. So we're making this a little bit bigger. And our detection sucks. There's no other way to say it. Our image detection here sucks. Or our vehicle detection sucks. We've just made entirely too many changes to this. All right. So drawing this, when we draw the rectangle doesn't seem to matter that much. Here we're adding the detection beforehand. We're drawing a rectangle up here. We're doing a dlib rectangle for each tracker. Sized image, get position. And drawing it from there, let's try the auto-suggested, because I've never done it this way. Let's try the auto-suggested code for that rectangle. Nope. POS before assignment. Let's see if it draws 2 rectangles. Nope. Okay, so the auto suggest wasn't helpful in that case. But we need to work on this algorithm for sure, because here we're seeing 2 cars, one of them which is not a car, it's that VidCom technology thing. And look at that, just stole the tracker and then stuffed it onto that parking sign. Who knows? Who friggin' knows why this thing is going so wacky? So we could just try speeding up this counter a little bit. That definitely helped. But it's not tracking the vehicles appropriately. As you can see, we say a vehicle's 500 something. So I think we do want to run the detection more frequently. I think we're on the right path there. I just don't know if every 5 frames maybe. Let's see what 5 frames does. We're back to not seeing anything. Silliness. What if we don't clear those trackers? Are we going to have thousands of them again? Probably. Oh, maybe not. I'm going to watch and see what happens to this tracker that's on the van right now. There we go. Now it's moving, moving, moving. That's following the truck. And then it stayed on the chair. So it's very interesting. It's holding on to these trackers for quite a while. It looks like it's not even clearing them. So that's interesting. Let's shift gears a little bit for the last 20 minutes, and let's do some pedestrian tracking. So pedestrian tracking, it's a little bit different. I'm going to we're just going to save find cars. We're going to reuse a lot of this code, but I'm going to save find cars where it is, even though it sucks right now. We're going to copy this, paste it, and rename it Find Pedestrians. We'll say findpeds.py. And for this one, we're going to find pedestrians. So instead of detect vehicles, detect people. Yeah, sure. Pedestrians. Frame classifier path. We'll do the same thing there. So we could actually even remove, I don't know. We're going to return final image and pedestrians here. We're going to see how little of code we can get away with changing, right? To make it detect pedestrians. So for our classifier math, this one instead, or classifier path, instead of cars XML, we need a hog. Let's see, OpenCV Hog descriptor, hog cascades. There we go. Google this. We have hog cascade pedestrians. This one has not been updated in 12 years. However, I think it might help. So in our models, we'll go to CD models, wget, and we're just going to download this straight from GitHub. Now we have hog cascade pedestrians. So copy that path. Find peds. We can close find cars. Hog cascade pedestrians. So as we go through here, this is our classifier path. Tracker. We're still going to rescale. Still going to resize. Instead of detect vehicles, now it's detect pedestrians. Resized image classifier path. Down here, I think we said, it looks like we just have cars for the terminology. So this stuff, yeah, should be fine. Like I said, it's we basically want to change as little as possible to this to make it work. So for a hog classifier, I do have some code here. Hog descriptor. We're creating a new hog descriptor, setting a detector, get default people detector. We're going to scale some of this stuff again. I'm going to scale it even more. Height width is frame shape. We're getting the height width scale factor 0.5. So we're slicing this thing in half. This is going to be our resized frame. And then we're going to count pedestrians off of that. So let's dump this one in. And so each of our pedestrians will be, we use a hog detector, detect multi-scale. We're going to detect that resized frame. Wind stride, I don't remember what wind stride is. But I think it's very similar to like a kernel size, like we've done in the other ones where we've done the kernel size stuff. We've got some padding, scale 1.5. So it's a resized frame. We're going to just let's see, return final image. That's right. We do need to do, instead of resized frame, we need to do final image, which in this case is a resized frame. We're not going to do any blur, any of that stuff. We're just going to pass it through. Let's see how this runs. If it runs. And it does run. Oh, and it's saying vehicles. We don't want it to say vehicles. We want it to say pedestrians. But as you can see, we're resizing this stuff before we're doing it. So we do need to resize equally, right? So I don't think we'll do a resized frame here. I think we'll just do a frame. So final image is frame. Run this again. And we're going to go back to the we're going to go back into, that looks like a pedestrian apparently. We're going to go back to the Times Square where we know there's going to be pedestrians for sure. Go up here, Times Square. And one thing I noticed is I'm drawing rectangles on both of these, which seems a little weird, but And it also seems weird that it's finding a pedestrian in that sign. A little wild. So detect pedestrians, classifier path. Why am I not using the classifier path? It's not accessed. What did I... Rescale the bounding boxes to original frame size. And return pedestrians. That's what I forgot to do. That resizes it back. So that's accurate. So return final image. Size frame. Okay, and then down here, pre-processed image is up here. And I did name that improperly, didn't I? Resized image. Pre-processed. I think I did a little confused today. It's been a long week. So here's our pre-processed image here that we're using, and we've probably scaled it down far too much because these pedestrians are not showing up on our pedestrian detection. Now what we can do, of course, is we'll throw in some, we'll grayscale it for one. We're not grayscaling it, so yeah, I'm not setting that. It doesn't look like I'm setting the hog descriptor on this thing either. So I'm probably just doing this wrong. Check something here really quick. I can figure out what I'm doing wrong. I'm not going to ask ChatGPT this time. I don't think it has enough context for the weird stuff I'm trying to do here, but that's set detector, hog descriptor, get off. Resize frame. So maybe I don't need to even download this hog cascade pedestrians XML. Like I don't need the classifier path. Anything like that. Let's do some of the things that we did here. Like at least let's do grayscale and see if grayscale helps. So scale factor, resize frame. We'll resize it. Let's make our final image gray. Let's see if grayscaling helps. Also, we need to update the text because the text is not accurate. It says vehicles equals, and we want pedestrians equals. Zero. It is not detecting pedestrians. It's just doing a very, very false detection there. Yeah, it should be detecting those other ones. Let's see if we have like our Amsterdam one where the pedestrians are a little bigger and see if that helps. Not, I'm going to work on this and figure it out. So I'm not going to be here next week. I'm not going to do the Computer Vision Power Hour or the Python Power Hour next week because I'm going to be doing a couple events next week, but I will be posting those on Pluralsight Live stream channel, so you might want to follow Pluralsight Live, which we're going to raid that channel today. But that's, yeah, I already lost my train of thought. What was I going to do? Oh yeah, video URL, Amsterdam, I believe this is. But yeah, next week I'm going to be doing a bunch of cool stuff, but I'll be doing it on the Pluralsight streaming channel. And this one, interestingly, is doing another false one over here. That sun is really messing with the Amsterdam camera right now. So this seems to be the worst time to do the Amsterdam camera. Let's see if I can find a pedestrian camera real quick. Like sidewalk, maybe. Live cam. Venice Beach. Had the chance to go here last year. We went to Southern California twice last year. Venice Beach is as cool as you probably think it is on TV. Let's check out Venice Beach. Oof. Does not like that one. No plugin error. Oh. How did that thing get so spaced out and weird when I pasted it? This should bring up the Venice. There we go. There's our Venice Beach camera, but it's showing no pedestrians yet. Other than this over off the side, so something weird sure is going on. I'm going to do a quick Google to see if I can figure out what I'm doing. This is a cold day in California because it's 57 degrees, 14 Celsius, pretty cold. Pedestrian detection, hog descriptor, set hog detector. Yep, I did that. SVM detector. Yeah, this particular article mentions NMS algorithms, and we do need to jump into that. Not today, but we need to jump into it soon. So we can get rectangles and weights from Detect Multiscale. I forgot about that. So instead of this way, we have pedestrians. See if we do rectangles and weights. Final image. And let's check that wind stride down. Yeah, maybe I just have way too much padding in here. I'm looking at that. I don't know what I was doing on that particular. Let's see, wind stride. On the particular app that I stole this code from originally, I'm not sure exactly what I was doing, but this might help actually. Most likely going to help me. And I'll go back to Pinewood Church. Still not detecting these quite obvious pedestrians. Let's see what else I'm doing here. Rectangles. Apply non-maxima suppression. Which I don't think I have this installed. We're going to pull these into the pedestrians into an NP array. We're doing that here. Scaling them for each pedestrian. Don't think that's an issue. Let's see. So maybe instead of resizing these like we were doing before, use a frame. So instead of resizing it, we're just going to pass it in the way it is. See if that helps a little bit. But we're just about done with the hour, so we're going to have to work on pedestrians on our next show. This says there are 15 pedestrians in here, but it's also not displaying those 15 pedestrians. I remember we dropped this in just kind of wildly, randomly a while ago, so. It seems to be counting the pedestrians, but not drawing a rectangle around them. So I'm messing this up. I'll do a little bit of research on it. So I will be gone next week on a trip. So I'm not going to be doing my streaming next week. However, well, I'm not going to stream here. I'm going to stream on Pluralsight Live. But I am going to investigate this a little bit further and see if I can figure out what I'm doing wrong on the pedestrian one and then share that with you, and we'll make the pedestrian one work. Now we've got more rectangles. However, they're barely accurate. Whole bunch of false positives. Just tons of false positive action going on here. Speaking of Pluralsight Live, let's check and see where they are at. If they're on here yet. Does not appear to be. So I'll keep looking here. Yeah, we got a whole bunch of false positives now that we're looking down at Charlie's Deli here. Just a whole bunch of false positive stuff going on over here. Yeah, let's see what happens when it zooms in. I actually like that this camera zooms in like this, because this gives us a chance to go a little closer, and it doesn't seem to affect anything. So our pedestrian camera thing here is not working so great. And there we go. There's my friend David. We are going to raid Pluralsight Live right now. So I stream once a week on Pluralsight Live. David streams once a week. I'm on Tuesdays. He's on Thursdays. So check it out. He's building a really cool game right now. We're going to go check that out. We're going to go say hi to David. And next week, you will want to check out the Pluralsight Live channel for sure, because they're going to do a bunch of cool stuff. We're going to be talking to a bunch of cool people. It's going to be a really exciting stream. Let's jump in and see what the heck David is up to. Thank you all for coming, and I will see you very soon.